Hi, I'm Dave Bergman, Vice President of International Relations for IPC, and I'm bringing you this week's IPC Technical Question of the Week. This week's question is related to bow and twist, IPC test method TM650 2.4.22. This test method has been around for many years. We still get some recurring questions every now and then, or some confusion, and I thought we would do this week's question. What we're going to be talking about is the difference between bow and twisted printed circuit boards, and looking at why there's some confusion in the twist test methods. A bowed circuit board is one that has its corners that can sit flat on a reference plane, and I'll show you an example in a minute on the table. You're going to be measuring this dimension and this dimension. Most of the time the bow will be bent up here. On a twisted board, you're looking for deflection or bow in the diagonal direction. So twist is really bow in the diagonal. So let's move over to the table and we can show you some examples. Okay, we've moved down to our demonstration table here, and we've got a couple cards here. These are simple promotional roadmap cards. And this one I've showed what a bowed circuit board would look like. In this case, all four corners are touching the reference plane, or in this point, the conference table. And when you're trying to measure bow, it's fairly easy. The 4 points are touching, you measure some shims, and you're trying to measure this deflection point off of the table. And you take that height, you measure the dimension across there, and that's essentially how you end up with your bow calculation. So much deflection over so much distance. It becomes a lot more complicated when I can't touch the 4 points to the board to determine my deflection. So for an example here, when I have a card that's now twisted, you can see that it's now the 4 points are not all touching. And there's a couple ways of measuring this. The quick way of measuring this is to restrain 3 corners and let the 4th corner stay free. And then you end up putting your shims on this 4th corner and measuring that deflection over this diagonal. And that is how you use the calculation. Because you're restraining 3 corners, it's actually taking the height of the corner and doubling what it might be in its normal state. In its normal state, if you look, and we have one shim here and one shim here with 2 corners restrained, these 2 ones restrained, what I really want to measure is the maximum deflection off the table. Unfortunately, in this case, that's in the center of the board underneath, and it becomes very difficult. There is a way to do this, and this is why it gets a little confusing, because there are 2 formulas in the 2.4.22. One of it indicates divide by 2. Divide by 2 is when you're restraining 3 corners and having the other one unrestrained. The other one is when you have shims. Now, when you have shims, you're going to have to really have some way of measuring that deflection in the middle. And so what most people end up doing is having some kind of gauge blocks under there, lifting this up, having an appropriate measurement here, and then actually building something up where they can physically get the accurate accurate measurement off of the reference surface in the middle. Anyway, that's bow and twist, and that's this week's technical question of the week. If you have a technical question you'd like us to address, please send it to answers@ipc.org.